Hello students, this is Poonam teacher with periodic classification of elements. In my last video, I have taught you modern periodic table. I have taught you that how many groups and periods are present into the modern periodic table. There are 18 groups and 7 periods present into the modern periodic table, and it is classified into S block, P block, D block and F block. Now in this video, we shall study electronic configuration, valency, atomic radius, and electronegativity, electropositivity, metallic and non-metallic characters of the elements. So let's start. What do you understand by electronic configuration? Electronic configuration is the arrangement of the electrons into the various shells of an atom. For understanding electronic configuration, we should know the structure of an atom. So how is the structure of an atom? The centrally located part of the atom is known as nucleus, and these are the shells of the atom. These are the shells of the atom. The first shell is known as K shell, the second shell is known as L, the third shell is known as M, and the fourth shell is known as N. In the nucleus of an atom, there you will find two particles, and that is proton, which carries positive charge, and neutron, which is chargeless. At the periphery of the nucleus, there will be electrons fitted as per the atomic number, and always the atomic number of an element is equal to the electrons. That means the number of protons and the number of electrons in an atom is same. Then are these electrons are randomly placed into the atom? No, it is not like that. It is present as per the rule, and that rule is 2n squared. That particular formula is 2n squared. Now let's see how. The general formula for the number of electrons to be fitted into the shell is 2n squared, and here the n represents the number of shell. So if it is the first shell, the K shell is the first shell, then in place of n, we will substitute the value 1. And what is going to be the total number of electrons fitted into the K shell? 2 into 1 square is 1. That means 2 into 1 is equal to 2. So maximum 2 electrons can be placed into K shell. Then L is second number shell. In place of n, we will write 2, square of 2. Then 2 into square of 2 is 4. 2 into 4 is 8. So maximum 8 electrons can be fitted into L shell. Then comes M. M is third number shell. So 2 into 3 square, that means 2 into 3 square is 9. 2 into 9 is 18. That means maximum 18 electrons can be fitted into third shell, that is M shell. Then N. N is fourth number shell. So two into 4 square is 2 into 16. 2 into 16 is 32. So maximum 32 electrons can be fitted into fourth number shell, that is N shell. So as per this rule, the electrons are arranged into the atom. So this is the meaning of electronic configuration. And this electronic configuration plays a very important role in the place which are given by Moseley into the groups and the periods into the periodic table. Then valency. What do you understand by valency? Valency is the number of electrons present into the outermost shell, or the number of electrons which are going to be lost or gained during a chemical reaction by an atom. So valency is the number of electrons in the last shell of an atom. Then what is the valency of sodium? The electronic configuration of sodium is 281. Do you know how this 281 came? Because the atomic number of sodium is 11. Na is equal to 11. That means the atomic number of sodium is 11. In first shell, maximum 2 electrons can be fitted. In second shell, maximum 8 electrons can be fitted. And 2 and 8, 10. Remaining 1 will be placed into the last shell. So what is the number of electrons present into the last shell of sodium? That is 1. So the valency of the sodium is going to be 1. Then what is the valency of aluminium? Atomic number of aluminium is 13. So electronic configuration will be 2, 8, 3. 2 plus 8, 10. 10 plus 3, 13. So 3 electrons will be present into the last shell. So number of electrons present in the last shell is the valency of that atom. So the valency of aluminium is going to be 3. Then let's study about the atomic size. What do you understand by atomic size? Atomic size, that means the size of the atom, and it is expressed into the form of the atomic radius. Atomic radius is expressed into picometers. This is the unit of atomic radius, and this picometer is even smaller than that of the nanometer, because 1 meter is equal to 10 raised to minus 9 nanometer, but picometer will be 10 raised to minus 12. 1 nanometer is equal to 10 raised to minus 9 meter, and 1 picometer, that means pm, is equal to 10 raised to minus 12 meter. So this picometer is even smaller than that of the nanometer, and atomic radius is always expressed into the picometer. Now what do you understand by this atomic radius? The atomic radius is the distance between the nucleus and the outermost shell of an atom. And you will notice that as you move from left to right within a period, you will notice that the atomic radius will go on decreasing. And why this atomic radius it goes on decreasing? Because the number of the shells will remain the same, but as the number of electrons is going to be more into the period. As we move from left to right within a period, every time you will notice that the number of electron will be greater than that of the previous box, and because of this the atomic radius will go on decreasing. Why? Because as the number of the electrons into the outermost shell will be more, the nucleus, which is positively charged, will create lots of strength and will try to pull those electrons towards itself. Pulling the electrons towards itself will decrease the atomic size, and because of that the atomic radius will decrease. But as you move from top to bottom into the group, you will notice that the atomic radius will start increasing, because the number of the shells will increase, the number of the shells will increase, and the atomic radius will also increase. Now let's study about the metallic and the non-metallic characters. Metals have the tendency to form cations. And why does metals form the cations? Because they have the tendency to lose the electrons to complete an octet into their outermost shell. Now let's see how. Into its valence shell. So all the metals will form cations. Cations are the positive ions. Positive ions. Hope you know what is the meaning of ion. Atom is electrically neutral, but when the number of protons and the electrons is not equal, a charge is created. So if the metal is losing the electrons, naturally the number of protons is going to be more, and because of that the positive charge on that atom will increase. It will be forming positive ion, which will be known as cation. And then non-metal. Non-metals will form anions. Anions are the negative ion. And how these negative ions are formed? These are formed because the non-metals have the tendency to accept or to gain the electrons. And because of this, the number of the protons and the electrons will not remain same. The number of the electrons will increase. the number of negative charge on that atom will increase, and because of that the atom will carry a negative charge, negative ion will be formed, and then that will be known as an anion. And always remember, whenever the number of protons and the electrons are equal, that is an atom, and atom is electrically neutral. But as the number of proton and electron will not remain the same, that will become a charged atom. Charged atom is known as ion. So positive ion will be known as cation and negative ion will be known as anion. On the other hand, we have already seen that ions have a stable electronic configuration of a noble gas. How is the ability to lose or accept electrons in the valence shell determined? All the electrons in any atom are held by the attractive force exerted on them by positively charged nucleus. Electrons in the inner shells lie between the valence shell and the nucleus. Because of their presence, the effective nuclear charge exerting an attractive force on the valence electrons is somewhat less than the actual nuclear charge. Thus, the number of valence electrons in metals is small. Also, the effective nuclear charge exerting attractive force on the valence electrons is small. As a combined force, these two factors have a tendency to use the valence electrons to form cations having a stable noble gas configuration. This tendency of an element called electropositivity is the metallic character of that element. See, I'll give you one example. Now magnesium. We will take the example of magnesium. Magnesium is a metal. Its atomic number is 12. This is the nucleus of magnesium. This is the first shell, second shell, third shell. The electronic configuration of magnesium will be 2, 8, 2. First shell will consist of 2 electrons. Second shell will consist of 8 electrons. And third shell will consist of 2 electrons. Now what will happen over here?